Hi, good afternoon, it's Dr. Michael McNeil here. We're getting to the time of year where it's so changeable. When it's heavy rain, then it's beautiful, glorious sunshine, and now it looks like the rain's sweeping in again. What I wanted to talk about today was, I think this is going to be quite a multi-part series because there's a lot to this, but I want to get into what a transcendental argument is. And there's a lot of background to fill in. That's like, in a sense, my book really is really laying the groundwork for a transcendental argument, really, regarding the necessity for the existence of God as a prerequisite for coherence, really, for intellectual coherence. And so, which is a big argument to make. It's a tough argument to make, which is why I was a PhD, really. But there's an enormous amount of background to that, and I think it's very, very useful to consider in general terms, sort of like the concept of proof as we move into this as a series. Because my last series I was talking about just analytical philosophy generally, just the analytic tradition, and I'm very much part of the analytic tradition, which means that to make a transcendental argument as an analyst, rather than to make a transcendental argument as somebody who's centered and focused in continental philosophy, means that there's quite a big tension between that, because the people who tended to have been strong transcendental arguments have been people who come from the continental side. So that's going to be an interesting exploration as to what is it that how can an analyst use transcendental arguments. So what I wanted to talk about today was the concept of proof. Because when we think about how in normal language or evidence proving things, and and to actually understand, there's actually probably 3 or 4 different sorts of, or different types of proof, which are associated with different philosophical schools and what they actually mean by proof. That's the interesting thing. That's something we'll come back to again and again, and it's also something which I think is extremely important for people who want to study philosophy and to actually understand philosophy, to actually understand that when we talk about evidence, when we talk about facts, when we talk about proofs, what is actually meant by those terms. They're not like universally abstract terms. They actually exist and have meaning within the language game that you're actually using. I'm not using that term game trivially here. I'm sort of like using it much as Wittgenstein would use that term, and Wittgensteinians who followed after use that term language. A game is just is the reason why he used game was because there's rules for a game, and sometimes those rules, in order to play that game, you have to follow the rules or you're excluded from the game. So we can talk generally about language games of science, or language games of sociology, or language games of psychology, or language games of art. Of what when you're talking about art, or when you're talking about poetry, or when you're talking about what, you will often have your own localized vocabulary, which if somebody's not familiar with the way you might be using the same signs, your words might be the same, but what's actually meant by those words and those signs is different, and that's a real major issue in the philosophy of language. And Wittgenstein in his later period, in his middle and later period, really picked up on that and developed that concept of the language game. And he said that he emphasized in his early years too much of as if the language game of science was normative for all other language games. And so it's really important, sort of like in philosophy, to understand the meaning of the terms which you're actually using, because a lot of the confusions and the errors which have turned up in philosophy have turned up because people have heard a term, or I mean, this is something, this is a general criticism of all philosophers. All of us will be guilty to a greater or lesser degree of this type of what I think I called it before, a bit of incoherence in our thinking. That if we actually think through, sometimes we won't realise when we're discussing an issue, and then we move on to another issue. We've said this is what we believe, but then later on, if you analyse, which is one of the reasons why analysis is so useful, when you analyse what I've just said, you suddenly realise, well, didn't you just say before that this is what you are basing it on? And that's why, in a sense, you have peer review and people who understand what you're talking about, and they say, well, actually, and then they come and say, well, if you actually really believe what you said you believe there, you can't say this. And so that's just the idea of, in a sense, of constructive criticism work. So this concept of proof. Now, the first sort of form of proof, which is perhaps the most radical form of proof, or the strongest form of proof, and that's what you would call a logical proof, or rational with a capital R, a rational proof. Because if you can remember, we were trying to make the general distinction between rational with a small r, which is just somebody who's trying to use their intellectual faculties and talk about the world, and but there was a school of rationalists. They were called Continental rationalists, who, like Descartes, Leibniz, Spinoza, they're the three great rationalists, and they had a particular concept of proof, and their concept of proof is a very strong concept of proof. It's a logical proof, and this in a sense is what you might say proof is deductive, which we'll go through all the way through back to Aristotle in particular. So a logical proof, if your premises are correct, then your conclusion follows inevitably from your premises, so your conclusion will be correct. That means that if at a later point one of those premises is shown to be false, then that invalidates your conclusion. So that's, if you like, the general taxonomy, which just basically means the structure of a logical proof. So a classical logical proof, probably the ones is all men are mortal. It's like one of your premises. Socrates is a man. That's your second premise. And therefore, which is your conclusion, therefore Socrates is mortal. So you see, that's inevitable. If those two premises are correct, your conclusion is certain. And so that's the great attraction of that form of proof, that the conclusions follow from the premises. And so one of the foundational principles of the rationalist school was that proof should be rational. Which makes sense. In a sense, proof should be rational or logical. So it should be, and what you do is you take those simple premises, you combine them into other arguments, and out pops a rational proof at the end. So something very simple, like that very simple self-evident form of argument there, all men are mortal, Socrates is a man, therefore Socrates is mortal, the idea was you would find lots of other simple arguments of that form, combine them together into arguments which are not self-evidential. You can just look at that and you can see that it's true, but you would combine those simple ones together to form complicated arguments, and those conclusions that flow out of those simple propositions are combined into this big argument, which are not self-evidential. They would provide you with logical and certain proofs about the world. And so you see this especially in Spinoza and Leibniz, that and with Descartes, obviously, because Descartes was of that thought, but you you find that their systems are very, very elaborate. They are coherent in the sense they are internally consistent, but the criticism that has always been that Descartes was a dualist. He separated between what he considered a reality or substance that is extended in space, so that's, if you like, your physical, your body, and between the mental, which he believed wasn't extended in space. He split reality between the body and the mind, which the mind he considered to be non-corporeal, non-physical, not extended in space, which is another way of saying that it's not, it's not made of what we would call matter. Now, Spinoza was a monist, and which basically means he believed that the physical and the mental are all the same stuff. There was just one stuff, starting from the same premise as Descartes, but came to a different conclusion. Now, the third great rationalist, Leibniz, he concluded that there was an infinite plurality of stuffs. He called them monads, monadology. So, without going into the details of monadology, which is one of those fascinating concepts which bears what word am I looking for here? It bears an unusual similarity to modern physics and its concept of energy, and which is sort of like remarkable, because he believed in, like, say, he was like an atomist, a logical atomist, believed in that reality was made up of distinct, non-related entities called monads, and that the great orchestrating monad he called God. And he was attempting to be, in his philosophy, which is another fascinating aspect of his work, as he was actually attempting to defend what he considered to be Orthodox Christianity. He wanted to defend a Christian view of the world, and he is also famous for his theodicy, which is like a depending. The theodicy is defending the ways of God. It's often considered a defense against the argument from evil, which we looked at in a previous video. So it's the three great rationalists, Descartes, Spinoza, and Leibniz, all had radically different views of the world. Descartes, on the face of it at least, Descartes was a dualist, Spinoza was a monist, and Leibniz was an atomist. And so now I did have a discussion with one of the examiners of my thesis. When he wrote a response, I went into a bit of correspondence with him about this particular issue, and he actually said that there was more similarity between the views of Spinoza and Leibniz than you might appear on the surface, because Spinoza had been censored by just about everybody. He was a Jew. He was actually a Dutch Jew based in Amsterdam, and he'd been censored by the Jewish authorities. He then got censored by the Catholics and the Protestants. So he really got censored. By Dr. Professor Almata, when he was giving me this feedback on the thesis, he made the point that Leibniz, although he didn't agree with Spinoza's monism, there was still quite a lot of similarity between their views. But I think the criticism, nevertheless, I think if you're not wanting to drill down into the intricacies of the rationalist view. I think you've still got that very stark problem with rationalism attempting to generate a worldview from the basic rational principle. So you're trying to combine these simple logical blocks together, which then generate something that's non-self-evident. So you're trying to get from the simple propositions are self-evident, the complicated webs of them are non-self-evident, but they're supposed to be this logical necessity. So it's a bit like Descartes was very much he was a great mathematical innovator as well. He came up with a new notation so many rationalists have been attracted to mathematics, if you like, knowledge modelled after mathematics, and that's not just a lot. I think a lot of that's an interesting, that idea of knowledge being modelling after mathematics appears and reappears in different philosophical schools, but it was very attractive to the rationalists because they were trying to say that this flows inevitably. But you then got the problem of the great rationalists, which is one of the reasons why rationalism, I wouldn't say it's in disrepute necessarily in modern philosophy, but it's certainly considered faulty. It's certainly considered almost, somebody would say, wounded beyond recovery, because it's got this basic problem of those who were alleging perfect rationalism and perfect deductions ended up with philosophies which were very different and worldviews which were very different and contradictory with one another. If you consider monism to be the exact opposite of logical atomism and dualism, again, to have they're very difficult to reconcile. They're all supposed to be rationalist, moving from perfect premises modelled after mathematics, with a logical necessity. For them to end with such diverse views would be considered self-contradictory. There's something wrong with it. But the idea of a logical proof, that's still, you still have to accept the importance of and the power of a logical proof. So that's why when people are learning philosophy, they do learn about logic, and the interesting thing is that you then find as well that there are logics. So there's not just one form of logic. There's not just Aristotle's logic and syllogistic logic. Aristotle's, syllogism was his most extensive contribution to logic, but also in Aristotle, that's the interesting thing, also in Aristotle actually used a transcendental argument to argue for logic, because he says that you can't argue about logic without using the concept of logic. So we'll just push that to the side. That's like a little preview because that's a very important, we will try and describe what's distinctive about a transcendental form of argument, but that's like, if you like, a little preview. But it's interesting to think that in Aristotle, who's most famous for his syllogistic style of logic of all men are mortal, Socrates is a man, therefore Socrates is mortal, that's what's called a logical syllogism. And that syllogistic form of logic, you don't necessarily even need, it doesn't mean you're always going to have more than one premise, because it doesn't, otherwise you end up with logical fallacies if you've just got a single premise and you're saying that the conclusion follows from that single premise. That's almost like, might be called, that's just called affirming the consequent or something. Obviously you're not deducing anything if you've just got a single premise. You're almost just like you're almost almost generating a premise, and you do find that fallacy in that appears when people are criticising particular arguments. Some people, you find it quite a lot, I think, in evolutionary style arguments where evolution is assumed in the premise before, rather than as a conclusion from it. It's almost like it's like a tautology. It's sort of implying itself, and so the most useful forms of syllogisms are when you've got more than one premise. Otherwise, you have to be very sharp with your. Logic isn't one of something I've studied in detail. So, I'm sure a logician, even at my level of understanding of logic, when you've just got a single premise, it's very easy to be fallacious in your logic, no matter what you're doing. So you're always going to want to, when you're working with syllogisms, you're normally going to want more than one premise, because that's what you're trying to group premises together anyway to say, well, this follows from your premises. So that's, if you like, the first type of proof, which is like a rational proof. Now the second type of proof, we could say, is what would be, I think a good way of describing it is like empirical proof. So where you're using empirical methods. So it's like if you wanted to ask the question, is it raining outside? And it's like, so is it raining outside? Yep, it is. How do I know? Because I look up and I can see the rain on the glass and I can hear it. And so it's like an empirical proof is because it's like, if this is interesting when we think about rational, where the difference between a rational proof and an empirical proof, because a rational proof has a logical certainty about it. But it's like if we were trying to come up with a syllogistic argument to answer the question, is it raining? We could have a big problem, because you might think, you would, even if you think about what's the barometric pressure, what's the wind, what's the temperature, what time of year it is, they might all be factors which would enter into, which you might try and generate and use as your premise and say, if the barometric pressure is underneath 999 millibars, and if the wind speed is above such and such, and you might then be able to say, and is the air pressure such and, in fact barometric pressure is air pressure, isn't it? But whatever factors we want to come up to try and say, is it raining, what time of year is it, what temperature is it outside, even if we have all those particular bits of information that we want to try and stick into our logical argument to try and decide whether it's raining, we would never be able to say by logical necessity that it is raining. We'd only be able to get so far. So the argument's not, is what we might call, it's like there's a fallible element. It's a fallible argument. You can't generate a syllogism to answer that question, and so that's one of the really interesting points that we should notice, that some questions cannot be answered by logical argument, and that is in fact a very important philosophical principle to actually understand, is actually to realise actually some arguments cannot be decomposed into logical parts to give us an absolute answer. They're always going to give us a degree of probability, whereas for an empirical argument, that's the interesting thing with an empirical argument, if you like, an empiricist proof, is you're actually confirming something. Your empirical argument is to do with the five senses, and so is it touch, taste, feeling, what are five senses? Vision, vision, hearing, touch, taste. But I'm sure, I know we have five senses, because when people talk about sixth sense of their intuition. But you're talking about something that can be measured, touched, and so that, if you like, is your empirical argument, or your empirical proof is going to be based upon taking data from the physical environment and then coming up with a argument that strongly suggests that conclusion, or answers the question, like, is it raining? Well, I'm looking, and I will use my observation. Where it becomes more difficult is, say, is it raining a couple of miles away? And so you would have to then take other empirical data, look at the data. If you haven't got a telescope or something, or even if you can see like a sheet of what looks like rain going across the sky, you have to understand that with empirical arguments, there is always a degree of fallibility to them, and so they are, you might say, that's a weaker form of proof, because there's fallibility with it. But the interesting thing about, say, like empirical arguments is that this is one of the reasons why Descartes rejected, if you like, empirical arguments, because he says that your senses were fallible, and he says if your senses are fallible in this instance, you can't rely on them for reliable you just can't rely on your senses. And so that's why he rejected like sense data as the basics. He said if you want to be certain, you have to use deduction. And so that would be a criticism of that view, is that how do you normally correct empirical observations which are false? So say I looked at something and I thought it meant that, you would make further empirical observations and that corrected your previous empirical observations. So, and that in many ways is what is assumed. Empirical proofs are very, very important, say, in scientific investigations and reinvestigations and reassessing your data. That's what you do so much of that when you're working, if you've ever done data analysis or research. And when you've a great example in, say, physics, which I know something about, is say Newtonian physics. You've got the great Newton's great sort of, he called it his universal gravitational equation, and it predicted, you can use Newtonian physics to predict the orbits of the planet around the sun, and you can do it with quite a commendable degree of accuracy. And when Einstein was, in a sense, revolutionising the understanding of physics in the early 20th century, he predicted that because of quantum effects, because Newton's assumption was that light was a wave, electromagnetic waves, and Einstein showed it was one of his earliest papers, I think. He showed that the light had packets, when there was packets of energy called photons, and he said that because these were like localized packets, they would be subject to a gravitational field, and they would be bent by a gravitational field, even though these are just like packets of energy, photons. He said that, and he predicted that there was an eclipse of Jupiter that was due, and he said that if you use if you used Newton's equations, because it was assuming light was a perfect wave, it wouldn't be affected by gravity, and the eclipse would be at this time. If you factor in with Einstein's with his equations, he was saying that because it's not these have got mass, these photons have got mass, and therefore they're going to be affected by a gravitational field, even though the mass of the photon is absolutely tiny, but it still has some mass, and therefore it's going to be influenced by a gravitational field. And he said because of that, the light is going to be bent by a gravitational field, by the eclipse, and the eclipse will be delayed by, I think it was something like maybe 20 minutes, because of the vast distance between ourselves and Jupiter. And so this was like a argument that was generated from empirical premises, and if it was true, then we can test this. There's like a hypothesis. You can test this as something fundamental in natural science. And so because nobody really considered that on the basis of the data, on the basis of previous observations. They'd never considered that was a possibility. And so a part of the process of empirical analysis or empirical investigation is where you might revisit your data to look at things you'd ignored because theories moved on. Somebody's come up with some other sort of theory which may be mathematical, maybe deductive, and you're then looking at what are going to be the implications of that new theory. And he said, well, we've got all this data. Maybe if we re-look at this data, we might see some of those effects. And that's exactly what happened with quantum mechanics.